So the equation for aerodynamic force is the drag force plus the lift force. So aerodynamic force is the sum of the two components of the force that are made in the x and the y direction. So aerodynamic force is just simply the drag force plus the lift force. But if we remember the definition of force, where force equals pressure times area, then we can use this equation to also rearrange and solve for pressure, because we know the force available in the wind. This comes from our lecture 3. Force available from the wind is this equation. Now, this equation, 1/2 rho a v squared, this is not the power of a wind turbine, although it looks the same. Remember, power of a wind turbine was 1/2 rho a v squared times coefficient of performance. Similarly, the force available from the wind was one step on our way to solving the power equation. So force from the wind, we knew from lecture 3, is 1/2 rho a v squared. So, but we know that pressure is force over area, so the pressure that is developed because of the wind is going to be 1/2 rho a v squared over area, over that same swept area, so the areas cross out. So we can conclude that the pressure from the wind is 1/2 rho v squared. So you see that pressure from the wind is directly related to the square of velocity of the wind speed. So therefore, we can calculate aerodynamic force by multiplying the pressure by this pressure that you can calculate here by the surface area. So let's do an example where we do that. So aerodynamic force is equal to the pressure times the area, which is also F lift plus F drag, which we don't need in this problem. But so here I'm exploiting this fact that force equals pressure over area, and I know the pressure that the wind is creating is 1/2 rho v squared, and I know the area in this question. So this would be 1/2. Density is 1.275 kilograms per meter cubed. And the velocity is 7.62 meters per second. That has to be squared, so the units have to be squared as well. The area is 0.9 by 0.3, and that would be the unit of meter squared. You would end up with 10, rounded to 10 kilogram meter per second squared. And of course, kilogram meter per second squared is a Newton. And what I did here is I crossed out this meter cubed with this meter squared in one of these meters, and that's it. And I'm left with kilogram meter per second squared. So that's how I would use this this force equation and the fact that force equals pressure times area.